All right, so the first question, you just click here and it opens in StatCrunch, and then you can go to stat, summary statistics, columns, variable 1, and you just hit compute. And here you go. That's the mean, 185.7, and the median is 185 because it's asking for both of them. Okay, any questions here? Okay, so you just enter the mean. The median, since the mean and the median are very close, they both represent the center of the data. If there are some extreme values, guys, please pay attention to this. If there are extreme values, the mean gets affected, is not resistant to extreme values, so it gets impacted by extreme values. And then in this case, the mean would not be a good representative of the center of the data sets. In this case, the median will be a good representative of the data set. But because the mean and the median, as you notice, are very much the same, they both represent the center. Now he asks you, what is the mode? The mode is the value that repeats most often. So let's see what the mode is. What do you think the mode is here, guys?
$24.
Do you see a value that repeats more than once in here?
240.
240. Okay, so the mode is 240. Do you think that the mode is a good representative of the center of the data set? Yes or no?
No.
No. Why is that?
Because it's
It
just
represents
whatever number
largest
repeats
value.
itself. It doesn't, it's not
Yeah,
necessarily.
it's the largest value. If it turns out to be the largest value, guys, then no, it's not. It's just the largest value. Let's say it turns out to be 120, the smallest value, then it won't be. But if it turned out to be like, let's say 175 or 180, close to what the mean and the median were, then you say, yes, it is a representative of the data set. But if you notice that it is on the extreme side, the lowest or the largest, then it won't be. Okay, let's go to the next question. Same question, guys. Oh, that's 1 of 72. Yeah, I want to leave. Oh, he wants us to attempt a question. Okay, we'll just put an answer. Okay. This data is skewed to the left. Without performing any calculation, determine which measure of central tendency best represent the graphed data. Explain your reasoning. What would you use when data is skewed, guys? The median. When the data is symmetric, it looks like, a bell shape, the mean is a best measure. When the data is skewed, you have to use the median. The median would be a better representative of the data set. But because when the data is skewed, that means there's likely to be an extreme values there, either on the left or on the right. We never use the mode as a good representative. It's either the mean or the median, guys. Okay. So the median. Okay. See this exercise here? That should get, because the data is symmetric, the mean would be a best measure here. Okay. Which data set has the greatest sample standard deviation? When the data is widely spread out, the standard deviation is large. When the data are close together, then the standard deviation is small. So in which data set, you guys, you think we have the largest standard deviation? Would it be the first, the second, or the third?
The third.
Okay, there's more spread out in the third, I agree. So that's number 3. Which data set has the least sample standard deviation? Where do you think the data are like
First
confined
one.
together? Would you guys agree it's the first one? Look at the data are gathering around
Yes.
the mean. And the mean is right 16. The mean is 16 right there. So because it has more entry closer to the mean. All right. If you do this practice test on your own, guys, you're going to see different, graphs and different numbers. So that's why I'm not trying to do the answers. So I'll give you a chance if you want to do it on your own as well. Okay. These are the basic probability questions, guys. 13 of 100 digital video recorders in an inventory are known to be defective. What's the probability that you select one it's defective? So it's not defective. So if 13 are defective, guys, then 87 are not defective, and the probability will be 87 over 100. He wants a decimal, so we can put 0.87. All right, and let's move on. This is a table. What's the probability that a voter chosen at random is in the 18 to 20 years old age group? Well, it's 4.6. That's the favorable outcomes divided by the total, guys. It just add them up. 4.6 plus 7.4 plus 23.4 plus 23.2 plus 53.8 plus 27.1 and put it in the denominator. So that's total here. Don't write this as an answer. My math lab will not accept this. Now we'll start with normal probability. Determine whether the graph shown could represent a variable with a normal distribution. Does this curve represent a normal distribution, guys? Yes or no?
No.
No.
No, because it crosses the x-axis. Actually, a normal distribution, guys, supposed to be go along with the x-axis but not touch. So it's supposed to be like this. So you just pick the answer that says this crosses the x-axis. That's why it could not represent a normal distribution. Oh. The curve could not represent her because the graph not skewed. The graph not because the graph skewed to the right. Crosses the x-axis. All right. You are correct. It's F. Okay. Find the area of the shaded region under the standard curve. So this is the area to the left, to the right of 0.77. And let me pause. So you go to second, distribute. It's normal CDF. Enter. Okay. Lower is the area to the lower bound, which is 0.77. So 0.77. Upper, guys, you know this tail doesn't cross the x-axis, doesn't touch, it extends indefinitely. And we agreed that indefinitely is 1,000,000. You can put 1,000,000 here or 1,000 for Z, doesn't matter. And when you do Z, when you work with Z scores, the mean is 0. This curve has a mean of 0 and standard deviation is 1. So by default, you're going to see 0 and 1, guys. And then hit paste and enter. And here you go. And he wants the answer to 4 decimal places. So you put 0.2206 as your answer. Now, if you like to use a static range for this one. Unfortunately, you cannot click here, so you'll have to have static range open, which let me open it. Using static range, you just go to stat calculator. This is a normal calculator, and where is the normal calculator? Right here. And you can see, guys, by default, it puts the mean is 0 and the standard deviation is 1. That's great. And I want the probability of z greater than 0.77. So look what you do, guys. Just change this to greater and put 0.77 right here and hit compute. And here you go. And it's the exact same answer as I got off the calculator. So when you put a mean 0 and standard deviation 1, you are in Z mode. It doesn't change the X to Z, but just you are working in Z mode. And when you use the calculator and static range, if you ask to find the probability of Z between, let's say 1 and 2, this is the between right here. You just click on this. For example, you put 1 and you put 2 and hit compute. And not only it will give you the answer, but it will graph it for you. So it's a nice visual for this. So that's the answer. Find the area between Z negative 1.3 and Z 1.1. Okay, guys, I'm just gonna use the calculator this time. You already know how to use static range here. And in between, it's very straightforward. For the lower bound, you put negative 1.3. And for the upper bound, you put 1.1. And 0 and 1. Always, if it doesn't give you a mean in standard deviation, be assured that it's about Z, not X. And you just put the value 0.7675. Next. Again, guys, same thing. You just normal CDF. You put 0, comma, 1.49, comma, 0, comma, 1. And you just process that. If some of you guys don't see, if you have an older TI 84 and you don't have the screen that I'm seeing, you're gonna see the following screen. So let me show you what you would see there. Just one sec. Okay. You might get to just this normal CDF. So you just enter the lower bound here, lower bound, comma, you put a comma, then you enter the upper bound and you put a comma, and then you put 0, which is the mean, and then you enter the standard deviation, which is a 1. Remember, when working with Z, the question is about Z, the mean is 0 and standard deviation is 1. That's what I like to walk out of today's session with this information here. All right, next. Find the indicated probability. See, that's an important chapter. You see quite a bit of questions in there. So probability of Z less than negative 1.15. I will bring the calculator up. So second distribute, normal CDF. What would be the lower here? Less than negative 1.15. That means my upper bound is negative 1.15. So what would be your lower bound, guys? Negative what?
1 million.
Yep. Still remember, put as many zeros as you want, guys. Even 1,000 would do it here for Z-scores, because you know, if you go beyond the 3, you have a very unusual Z-score. All right. And here you go. And the answer will be round to 4 decimal places, 0.1251. But if you redo this question later, don't be surprised if you see a different answer, because this number could change. The system could change this number as well. Probability of z greater than negative 0.47. So that's going to be normal CDF. Your lower bound is going to be negative 0.47. Your upper bound is the sky is the limit, comma 0, comma 1. Just enter those. This will be lower bound, upper bound, mean, standard deviation, and should get the answer. The system provides you the table with the table, but as you notice, guys, my philosophy in this course was to use technology and be able to interpret technology as much as possible. You can use those tables, but you have the option not to. And I emphasized on the use of technology in my class anyway. Now, assume that the random variable x is normally distributed with a mean of 80 and standard deviation is 4. Find the indicated probability. This is going to change slightly, guys. So we're going to go to second and variable, normal CDF. We don't use normal PDF, guys. It's just normal CDF. Okay. My lower bound is 70. My upper bound is 77. My mean is not 0, 1. It's about x now. And when it is about x, he has to give you a mean and he has to give you a standard deviation. So what is the mean is 80. And the standard deviation is, so 80. And let me just read. The standard deviation is 4. And press enter. There you go. 0.2204. Let me, I'll show you later on static range. When you use a static range, guys, make sure to change the mean from 0, 1 to 80 and 4, and then enter in between 70 and 77. You will get the same answer. Okay, so that's a 0.2204. And let's proceed to the next question. In a recent study on world happiness, participants were asked to evaluate their current lives on a scale from 0 to 10, where 0 represents the worst possible life and 10 represents the best life. The responses were normally distributed with the mean. So the mean, guys, is, this is the mean, mu, of 6.3 and a standard deviation of 2.4. So it's not about z here, it's all about x. Find the probability that a randomly selected study participant response was less than 4. So let's bring the calculator. And we can answer all those questions on the calculator. First one. Second and distribute, normal CDF. Okay, so lower, less than 4. So it means when it is less, guys, you have to start with negative a million or a billion here. Always less, you start with this. And then if he says less than 4, that will be your upper bound. You cannot go beyond 4. And then the mean is 6.3. And the standard deviation is 2.4. And here you go, 0.1689. Next question. What's the probability the randomly selected study participants' response was between 4 and 6? That should be very straightforward, guys. Normal CDF. 4. And by the way, guys, there are 70 questions here. Don't expect the final exam to be that long. Just this is a review, a study guide, so it has more questions than the exam. So we said 4 and 6. Okay. And enter. And your answer is 0.2813. Make sure to round it properly, guys. Find the probability that a randomly selected student's participant response was more than 8. More than 8. Let's see how we do this. Second variables. Anything that is in blue, you have to press the second key first to get to access it on the calculator. More than 8. So 8 and up. So your lower will be 8 and your upper will be the sky is the limit. See, I put as many zeros as I want. And don't change the mean and the standard deviation because they're all from the same question. 0.23936. Okay, so you put that in there. And then the last question, he says, identify any unusual events. An event is unusual when the answer, the probability is less than 5%. As you notice, guys, all those answers were more than 5%. There are no unusual events in here. I would choose D. All right, that's clear. In a recent study, recent year, the scores for the reading portion of the test were normally distributed with the mean of 20.3 and standard deviation completes very much, guys, the same question. So for this one, the probability of a student scoring less than 19, it will be normal CDF. Less than 19, you begin with a million, negative a million, then 19, then the mean, which is 20.3, then the standard deviation, which is 5.1. Don't put the standard deviation before the mean. It's lower bound, upper bound, mean standard deviation. For the next one, it's between, so that will be normal CDF. 14.4 is the lower bound. 26.2 is the upper bound, and the mean does not change, 5.1. For the probability that a randomly select high school students has a score more than 30.5. You notice, guys, I'm testing you on all inequalities, greater than, less than, and in between. So 30.5 right here, then a million, then 20.3. You have to put 4 arguments there, 5.1. Now, identify any unusual events. If any of the answers, guys, is less than 5%, you select it as unusual event. Okay. Find the z-score that has 1.5% of the distribution area to its left. Let me do a sketch here and show you how to do this. All right. So this is what we need. We need the z-score. That's a 0 here. So you know the answer has to be negative because it's below 0. Do you still remember what feature do we use in order to find z-score? So this time it's a reverse order. He's given us the probability and he wants the z-score. In the previous questions I did, guys, you are given, just numbers and you are asked, just to find the probabilities. So it's the other way around. Do you still remember what feature do we use on the calculator to find this one?
Is the inverse norm?
Yes, it's the inverse norm. Oops. The screen turns. And I'll done with the calculator in a second. And you enter the following. You enter the area to the left of the target, which is 1.5%, so 0.015. You have to enter it as a decimal. And you enter the mean and the standard deviation. Since we're working with Z, guys, it's 0, 1. And here's how you do it on the calculator. Okay, just one. Second, bring the calculator. So you go to second, variables. It's the next one, guys. It's inverse norm, area 0.015. And that's it. You don't do anything else. Just leave the rest alone. and it's negative 2.17. And it does make sense. It is negative and it's toward, just the far left. So it's negative 2.17. There you go. Let's move on. The test scores for the analytical writing section of a particular standardized test can be approximated by a normal distribution as shown in the figure. Here it's not Z, it's X. He gives you the mean and he gives you standard deviation. What's the maximum score that can be in the bottom 20%? Okay. So the area to the left, guys, will be 0.2. And then the mean would be 3.2. And standard deviation is 0.79. And we will be using, again, inverse norm to do this. Okay. So let's bring the calculator back up. Let me clear everything. Second, distribute. Inverse norm. Okay, so 0.2. Mean is 3.2. Standard deviation is 0.79. And for sure, guys, your answer is going to be less than 3.2 because it's an area below the mean. So you will see that it's going to be less than 3.2 because the mean is 3.2. Here you go. He wants the answer to 2 decimal places, so you just put 2.54. Let's do the next one. Between what two values does the middle 60% of scores lie? So let me do that. Let's clear the drawing and the middle. Let me show you how the middle would work here. He wants those two values. Okay, if this is 60%, how much is left for this tail, guys?
20.
Yeah, because 40% split them up, I agree. Okay, here's how we find x1, guys. X1 will be inverse norm area to the left of the target, so 0.2, which you already did it, 3.2, and then 0.79. We've done that already in part A. X2, it's going to be inverse norm. It's always the area to the left of the target, guys. Can you guys tell me what's the area to the left of X2? Let me use a different color. This area. What would that be?
80.
Yep, 80. Another way to figure it out, guys, you know that this is 0.20. Well, if the area to the right is 0.2, then the area to the left must be 0.8. So these two, they add up to 1, as you notice. 0.80, 3.1, or 3.2, 0.79. And you'll be done. So it will be between 2.54, and then for the second one, guys, if you want to find it, it's going to be more than 3.2, of course. So that will be second, distribute, inverse norm, area is 0.8, and say leave everything the same, guys. Paste. This is 3.86, so it's between 2.54 and 3.86. The red blood cell counts in millions of cells per microliter for a population of adult males can be approximated by a normal distribution with the mean of 5.7 million cells per microliters. So we got the mean and we got the standard deviation. Oh, that's annoying here. Okay, now it's working. So that's the mean. Just want to circle that. And that's the standard deviation. What is the minimum red blood cell count fat that can be in the top 23% of counts? That's different now. It's a top, guys. You should go to the right. So this is going to be 23%, this area. And we need this value. Okay. So it's going to be inverse norm. Let me type it in. Just type the formula, guys. Okay. What would be the area to the left of my target? Don't put 23%. This is the area to the right. The top is giving you an area to the right, but the formula requires the area to the left. So what would be your area here, guys?
77.
Yep. Does everyone agree? Comma, 5.7, comma, 0.3. And you do this, guys, and you get the answer. B, what is the maximum red blood cell count that can be in the bottom 14% of counts, guys? For bottom 14%, that's a different story. It's going to be right here. Come on. Okay. This is my 15%. That's where it is at the bottom. The bottom is on the left, guys. And we need this X value. And this is going to be, guys, what? Inverse norm. And since the area happened to be on the left, so we're good. Just use it as is. 0.15 and then 5.7, guys. And then 0.3.
You mean 14?
Oh, 14. Oh, they say 14. Yeah, you're right. I would have gotten this wrong on the test, guys. I put 15. So read the question more than once before you answer it. So it will be inverse norm 0.14. I'm going to type it in. 0.4, but you still have to do the math, guys. You need an answer here. 5.7, comma 0.3. Just for the sake of the recording, I just put in this, and you can use your calculator to do that. All right, that's clear. A population has a mean of 72 and a standard deviation of 23. Find the mean and the standard deviation of the sampling distribution of sample means with a sample size of n equals 257. This is the central limit theorem. We're getting to the good stuff here. And let me show you guys. Let's say this is X. This is the original population. It has a mean and it has a standard deviation. Let me show you what X bar looks like. Same mean. Just 1 second. I don't know if you see that the screen is turning blank, but okay, we'll have the same mean, mu, that's X bar, but the curve is narrower. The standard deviation will not be the same as the original standard deviation. The sigma of X bar, this is what the central limit theorem says. It will be the original sigma divided by square root of n. So to answer this question, resume recording. So mu of X bar, always, guys, the mean of the sample means is the same as the original mean, but the standard deviation of the sample means will be the original standard deviation divided by square root of n. So for this question, guys, your mean will be just the same, which is 82, but your standard deviation will be 30 divided by square root of 250. And if you bring your calculator and compute this one, it will be 30 divided by, you scroll down, square root 250, that's the sample size, and exit and enter. It's 1 point, how many decimals? He says 3 decimal places, it will be 1.897. That would be your answer. Okay, let me clear here. The population mean and standard deviation are given below. Find the required probability and determine whether the given sample mean would be considered unusual. For a sample of n equals 61, find the probability of the sample mean. So it's not the probability of X now, guys. It's a probability of X bar. He wants a probability of X bar, the sample mean. Less than 22.2. Okay. We have mu is 22, sigma is 1.22, and we're gonna go to normal CDF. So I'm gonna go to the calculator, guys, watch. But just pay attention how we're gonna do this. Clear, I'm gonna go to second and distribute, normal CDF. Okay, less than 22.2, so lower bound is -1 million, just like before. Upper is 22.2. The mean is the same as the mean, which is 22. Standard deviation, this is where you have to pay attention, guys. So what is the standard deviation here? 1.22. So look what you enter here. You enter 1.22 divided by, because you're working finding the probability of the sample, not the probability of an individual. You divide by square root of n, which is square root of what's n here, 61. And then hit paste. So anytime the question is about X bar, you do exactly the same thing as you did before, but instead of sigma, you have to put sigma over square root of n. And enter. It's 0.8997. Okay, would the given sample mean be considered unusual? No, because the answer is more than 0.05. Okay, so just put the answer 0.899. Sorry. So the mean sample would not be considered because the probability is greater than 5%. Next question. Use the central limit theorem to find the mean and the standard error of the mean. The standard error of the mean, guys, means sigma of X bar, which is sigma over square root of n. So it's the same thing. This is sigma over square root of n, which is called sigma of X bar. The sketch of the graph, then sketch the graph of the sampling distribution. The mean price of photo printers on a website is 238. So 238 is the mean, which is the same as mean of X bar. So mean of X bar, guys, will be, we need the mean of X bar and sigma of X bar. So mean of X bar will be 238. That doesn't change. Now sigma of X bar. Let's see. With a standard deviation of 61, random samples of size 30 are drawn from this population and the mean of each sample is determined. So what would be sigma of X bar? Will be sigma 1, which is original sigma 61, divided by square root of 30. Okay. And what would that be, guys, if I bring the calculator back? 61 divided by square root of 30, enter. So 11.14. Okay. Now, guys, you have to look at the graphs and tell me which of the graphs show a mean of 238 and a standard deviation of 11.14. Meaning, toward the end of the curve, you should see 238 plus 11 plus 11 plus 11 minus 11 minus 11 minus 11, because it goes 3 standard deviation to the right and 3 standard deviation to the left. Well, I can tell you guys for sure that this is not one of the answers because it's Z. So that can't be this. It must be 1 or 2 or 3. Which one do you think is going to be our answer? It can't be B, because 238, if you subtract 11 and you subtract, I'm just saying approximately 11, and another 11 and another 11 is not going to go down to 235. It's going to go a lot lower than 235. So that can't be the answer. We're between A and D. Now it should be easy to guess, guys. Is it going to be A or D? What do you guys think?
D.
I agree. If you go 11, 11, 11, about 33, 238 minus about 33, look, 205, almost 205. And if you go 11, 11, 11 to the right, it's going to be about 70, 270. Yeah, look at this one, it goes to 421 and 55. So that's not that good. That's the answer. That's how you can figure this out. All right. So we need to provide an answer. So the system will allow 238. And we said the standard deviation will be 61 divided by square root of 30. And we selected this one. The mean percent of a childhood asthma prevalence in 43 cities is 2.38%. A random sample of 34 of these cities is selected. What's the probability that the mean? So it's about X bar again, guys. This is about X bar, central limit theorem. He wants a probability of X bar of the sample is greater than 2.7%. Okay. Assume that original sigma is 1.2. So here's how we do this. The probability will be normal CDF okay, greater than, we begin with the number that right after 2 greater than 2.7, then a million, then the mean, which is what, 2.38. Now, probably some of you would wondering why I'm not changing percents to decimals. I could, but since everything is in percent, I'll just keep it as a percent. I'll just keep the number. And the answer will be fine, 2.38. Okay, standard deviation, guys. You have to be careful here. It's not 1.25. It's 1.25 divided by the sample size. And the sample size, guys, is 43 cities. So just divide by 43. And then you can get the answer. That would be it.
Isn't it 34?
Oh, what is it? Oh, 34. I'm sorry. You are correct, Sab. And then you do the math and you just get the answer. You have to fill in the blanks here. Okay. Okay, probably that's the last question in this chapter. The mean height of a woman in a country, that tells you how important this chapter is, guys, normal distributions. The mean height of a woman in a country aged 20 to 29 is 64.1 inches. A random sample of 50 women in this age group is selected. What's the probability the mean height of the sample is greater than 65? So it's going to be normal CDF greater than 65, 65, then a million. Then the mean is 64.1. Then the standard deviation, guys, is 2.68 divided by square root of 50. Of course, you need to do the math here and just do, you can do it on the calculator to get the answer. You construct a 95% confidence interval of population mean using a random sample. The confidence interval is, this is just for the definitions, okay. You construct a 95% confidence interval of population mean using a random sample. The confidence interval mu is between 24.9 and 31.5. Is the probability that mu is in the interval 0.95? No, this is not a probability. This is a confidence level. With 95% confidence, we can say that the mean is between 24.9 and 31.15. Okay. Use the confidence interval to find the margin of error and the sample mean. If you have the confidence interval, guys, and you need to find the margin of error, you subtract the lower bound from the upper bound and divide by 2. So actually your margin of error, if I bring my calculator, guys, it's going to be 1.99 minus 1.57 and then divide by 2. It's 0.21. If you have the interval and you are asked to find X bar, the sample mean, you add up and divide by 2. It's right in the middle, guys. So it's going to be 1.57 plus 1.99. You add them first, you add the top first, and then divide by 2. 1.78. Okay, next. Use the confidence interval to find the estimated margin of error. Well, the estimated margin of error, again, guys, as I told you, it will be 4.5 minus 4.1. It's easy to find the margin of error when you are given the interval divided by 2. The sample mean is 4.5 plus 4.1 divided by 2. You are given a sample mean and a population standard deviation. You are given the population standard deviation. Please pay attention to this. So you're given sigma. Use the information to construct a 90 and 95% confidence interval. A random sample of 45 home theater systems, so that's N, has a mean price X bar, and sigma is 15.2. When sigma is given, guys, when the population standard deviation is given, you cannot use T, you must use Z. So it's going to be a Z interval here. This is the hint. This is the big hint. You use a T interval, you're going to give me wrong intervals because he gives you sigma, it must be a Z distribution. So let me remind you how to do that on the calculator. So stat tests Z interval. Oops, sorry. Enter. Okay, I have a summary. I don't have data, so just use stats. Okay, you see the prompt, guys? It asks you for sigma, and he gave you sigma here. And what was sigma in there? 15.20. Okay, 15.20. X bar, 132. N is 45. And let's do 90% first. You can put 0.90 or 90, either way the system will accept it. And that's the first interval. So the 90% confidence interval, he wants 2 decimal places. So 128.27, 135.73. Now 95% confidence interval. So you go to stat, tests. Let me just clear the interval again, guys. And it's the same thing everywhere, guys. I just need to change this to 95. You remember the 95 is wider always than the 90% interval. So you get the 127.56 and interpret the results. With 90% confidence, we can say that the true mean is between 128.27 and 135.73. And with 95% confidence, we can say that the true mean is between the two values that you came up with. So you just select the proper answer. And let me tell you which one is not the correct answer. With 95% confidence, it can be said that the sample mean, no, it's not about the sample mean, it's about the population mean. We already know the sample mean, which is 132. We do confidence interval to make conclusion about population, not samples. Public lies in the second. Oh, he says the 95% confidence interval is narrower than 90%. That's not true. So it must be C, guys. It's wider. Always when you go wider, the interval, when you go with the higher confidence level, the interval will go wider. Find the critical value to see for the confidence level 0.98. We can use the calculator here, or you can use the table. If you open the table here you go, guys. It's already has a 98. And what's the degrees of freedom? N is 29, so degrees of freedom is 28. So just scroll down to 28 and then look for 98 and find it from there, right here, 2.467. But if you want to use the calculator, so this is for this is what you can do using the calculator. Let me just prep the work for use the calculator. You take 100%, because the interval has 2 tails, to the left and to the right. So we need the area to the left. So we'll do 100% minus 98%. Always, you just do what I'm doing right now. You get 2%. Take the 2% and divide it by 2. Which is 1%. And go to inverse T now. Because it's a TC, so it's inverse T. If it was a ZC, it will be inverse norm. Enter the 1%, which is a 0.01 as a decimal. And enter the degrees of freedom, guys, which is 29 minus 1, which is 28. Let me show you. I'm going to go to second, distribute, inverse T. Oops, I put the wrong formula. Second, distribute, inverse T. Oops, let me quit. Second and quit. Clear. Second and distribute. Area. 0.01. Degrees of freedom, 28. Paste. .467. Exactly. It's going to be negative because you will have one negative and one positive, but he wants just the positive one. So for the confidence level, guys, you have the two values, one on this side and one on that side. When you use your calculator, it's going to give you the negative one, but you just put 2.467. All right. Let's clear all drawing. In a random sample of 24 people, the mean commute time to work was 34.7 minutes, and the standard deviation was 7.3. He didn't say population standard deviation, so that's S, guys. That's what you need now to distinguish. So this is me, X bar. And he says, in a random sample of 24, from the sample of 24, the mean was 34.7, and the standard deviation, he's still referring to the sample S. Assume that the population is normally distributed and use a T distribution. Well, actually, he gave you a hint here. Use a T distribution, not a Z distribution, to construct a 98% confidence interval. Okay, that should be very straightforward since he even gave us the hint. So you go to stat, tests, T interval. Don't use Z interval. He's even telling you use a T distribution. Okay. X bar 34.7. S, what was S, guys? 7.3. N 24. And 98 confidence interval. And hit calculate. So the confidence interval is 30. How many decimals does he want? 1 decimal. So it will be 31.0 and 38.4. The margin of error, since you have the interval, guys, you can subtract the two values and divide by 2, you get the margin of error. Interpret the results. It can be said with 98% confidence that the mean commute time is between 31 minutes and 38.4 minutes. Which one says that? There you go, right here. With 98% confidence, it can be said that the population mean commute time is between the bounds of the confidence interval. It's all about the mean, guys. So I know here it says the commute time. No, it's all about the mean commute time, mu. This chapter, guys, is about making conclusion intervals for mu and the proportion. All right, so let's move on. And that's clear. In a random sample of 5 mobile devices, the mean repair cost was $70 and the standard deviation was 11.50. It's pretty much probably the same, guys. So that's X bar. That's X bar. That's N. That's S. That's S. Assume that the population is normally distributed. Always you have to assume that the population is bell-shaped. And use T distribution to find the margin of error, construct a 90% confidence interval. So guys, just like we did earlier, clear, stat, and it's a, oops, I'm going too fast. T interval. I don't have data here. If you have data, you have to select the data. Oops, what did you select? Select the wrong test. Went too far. Okay, now 8. So X bar, guys, is 70. S, what was it? 11.50 dollars. N is 5. And confidence level, he wants 90%, correct? So it's 59.04 and 80.96. 59.04 and 80.96. To find the margin of error, you can use the formula, or you can subtract the lower from the upper and divide by 2. I know that's faster for you. And then interpret the results. It can be said that the population mean cost is between the bounds of the confidence interval. Okay, now we're doing proportion. Let P be the population proportion for the following condition. Find the point estimates for P and Q. A point estimate for P, it's called the P hat, which is X over N. So I'm just putting the formula for you guys. And if you want to do the math, that would be equal to what? A survey of 1,399 adults found that 336 said that they were not confident that the food they eat in country A is safe. So it will be 336 divided by 1399. Okay, let's see what the answer is here. 330. This is called the point estimate for the proportion. A point estimate for the mean will be X bar. And the point estimate of the proportion will be P hat, which is X over N. Okay, so it is 3 decimal places. You would write 0.240. Who can tell me what would be a point estimate for Q hat? Once you know it for P hat, guys, it's easy to figure it out for Q hat. So if it is 0.240 for P hat, what would it be for Q hat?
0.76.
Yeah, they add up to 100%. I agree. In a survey of 2,127 adults in a recent year, 1,397 said that they have made a New Year resolution. Construct a 90% confidence interval and 95% confidence interval. No problem. That could be very easy question using technology. Couldn't be any easier than this. So you go to one prop Z interval, guys. I think it's not, it's after 9. Yeah, it's A. You need X and you need N. X here is the smaller number, 1397. And N is the larger number, which is 2127. Confidence level, he wants the 90. We'll do the 90 and then you go back and do the 90%. Okay. So he wants 3 decimals. So it will be 0.640 and 674. 0.640 and 0.674. Then you do the 95%. Same thing, guys. Just go to stat. There are shortcuts to get to A, but I'm not gonna go over that now. See, I went too fast. So just change the confidence level, guys, to 95. You get 0.637 and 0.677. And the 95% confidence interval, you just put 0.637 and 677. You notice the lower bound is lower than the first one and the upper is larger than the first one. So the interval 95% is wider, definitely. It can be said that population proportion of adults who say that they had a made New Year's resolution is between the endpoints of the given interval. A researcher wishes to estimate with 99% confidence the population proportion of adults who think Congress is doing a good or excellent job. Her estimate must be accurate within 4%. Okay, the 4% is the margin of error, guys. That's E. And we need a 99% confidence interval. No preliminary estimate is available. Find the minimum sample size. Well, there is a formula, guys, for the minimum sample size when you do proportion. I'm going to write the formula. And I think if this question shows up on the test, it will pop up. The formula will pop up as an instructor tip. Okay, here is how you answer part A. If he doesn't give you a preliminary, here you can't, there's no program on the calculator to do this for you guys. You have to use the formula. If he doesn't give you a preliminary estimate of P hat and Q hat, statistician decided to make a compromise and I'll give a P hat 0.5 and a Q hat 0.5, 50-50. So you start with N equals 0.5 times 0.5, that's Q hat, times ZC. This is the critical value at a 99% confidence interval. Actually, guys, I ask you to try to memorize those values. At 90%, it is 1.645. At 95%, it's 1.96. And at 99%, it's 2.575. And how do you find this critical value? You have to take 100%, subtract 99%, which is 1% divided by 2, it will be 0.005. And then you go to inverse norm and you put inverse norm 0.005, comma 0, comma 1, you'll get the 2.575, but you can memorize this. Over the margin of error, it's 4%, change it to a decimal, guys. And then square. And let's see what the calculator gives us here. So 0.5 times 0.5 times, open parentheses, 2.575 divided by 0.04, close parentheses, and then square. Okay. Round to the nearest whole number as needed. Okay, so you have to round up always. When you do sample size, guys, you round up. Even if it is 1036.035, it goes to 1037. For part B, what's the minimum sample size needed using a prior study that found that 38%? So he gave you P hat here for this part. So we have a prior knowledge of P hat. P hat is 38%. So the formula is going to be for B, guys. N is 0.38. I'm not going to put 0.5, 0.5 because we know P hat. If P hat is 0.38, guys, it should be easy for you to figure out what Q hat is. It's 1 minus 0.38. And then 2.575 divided by 0.04 squared. Okay, let's see what the answer is going to be here. So I'm going to bring the calculator back up. Clear. 0.38. 1 minus 0.38, guys, is 0.62 times, open parentheses, 2.575 divided by 0.04. And enter. 976.35, you make it 977. And definitely having an estimate will give you a smaller sample size, so it will be A. All right. Clear.
Professor Bezzi,
Yes.
could
Now, I have probably students from my section 98 and 99. This is only for my students in section 98 and 99. If your null hypothesis will always have that equal sign. So when you see me putting something other than the equal sign, don't be alerted. It would still be an equal sign because this book, as I told you earlier, this book does it this way. That's important before I continue. So for my group C1, it's going to be this way for setting up the hypothesis, either this combination or that combination or this one. For section 98, 99, I don't want to confuse you guys, but I have to make it clear to my students also, or our guests here. It's going to be always for HO an equal sign, and for HA or H1 will be one of the ones that I listed there. So don't think that I'm doing anything different here. The results will be very much the same. Okay, so use the given statement to represent a claim, write its complement. What would be, guys, the complement of less than or equal to? You guys agree that it's gonna be this, greater than. So if you wanna select which one is HO and which one is H1, you will go less than or equal to, that will be the one. For the statement below, write the claim as a mathematical statement. State the null and the alternative hypothesis. The standard deviation of the base price of a certain type of all-terrain vehicle is equal to 301. So do you guys agree with me? It's going to be equal and not equal to. For both the groups, it doesn't change here. So it's a clear old drawing. So equal and not equal to. Okay, the claim. The claim happened to be in the null hypothesis because he says equal. Remember, the null hypothesis is a statement of equality. So sigma is equal. Choose the correct null and alternative hypothesis below. That would be this. Identify which one is the claim. The null hypothesis is the claim. Okay, describe type 1 error and type 2 error. Let me tell you what type 1 and type 2 are, guys. Type 1 is when you reject the null hypothesis when it is actually true. So you're rejecting something that is true. That's a mistake. They call it type 1 mistake. Type 2, when you fail to reject the null hypothesis when it is false. If you fail, guys, to reject something that is false, you've made another mistake. This is called type 2. So a lumber store claims that at least 80% of its new customer will return to buy their next order of lumber. At least is this sign. Let me show you. So at least is that 80%. It's a proportion actually here. So greater than or equal to 80%. That's what at least means. And what would be the opposite of this statement? And it turns out to be in the null hypothesis. And what would be the alternative? B is less than 80%. Okay. What's a type 1 error? When you reject HO when it is true, that means at least 80% of the customer are going to return, but you reject this statement. And a type 1 error occur when the actual proportion of new customers is at least 80%, but you reject it. Just this is the definition. What would be a type 2 error? When the actual proportion of new customers to buy their next order is less than, it's not, this is false. Type 2 error means HO is false, but you fail to reject it. If HO is false, that means HA is true. If one statement is false, the other statement is automatically true, guys. So that means the proportion is less than 80%, but you fail to acknowledge that. Okay, so that would be type 1 and type 2 error. Okay, let me clear. Determine whether the claim stated below represents the null or the alternative hypothesis. If a hypothesis test is performed, how you should interpret the decision that rejects the null hypothesis or fail to reject the null hypothesis. A scientist claimed that the mean incubation period for the eggs of a species of bird is more than 43 days. Okay, guys, do you agree with me that the claim is in the alternative? Mean is more than 43. That must be an H1 or HA. Okay. Does the claim represent the null or the alternative hypothesis? Since the claim does not contain an equality statement, it represents the alternative hypothesis. The equality statement, guys, these are all called, just one sec. This, that are called equality statement. And that's why my other book, get rid of all of them and replace them with the equal sign, because they represent equality statements. So the null hypothesis is a statement of equality. The alternative hypothesis is a statement of inequality, greater than, less than, not equal to. How should you interpret a decision that rejects the null hypothesis? If you reject the null hypothesis, guys, and your claim is in the alternative hypothesis, then you support the claim. There is sufficient or enough evidence to support the claim. How should you interpret a decision that fails to reject the null hypothesis? If you fail to reject the null hypothesis and your claim is in the alternative, then you cannot support the claim. So they say that there is insufficient evidence to support the claim. Okay. Clear? We haven't gotten into actual hypothesis testing question. The p-value is shown here. And this is the level of significance. Remember, guys, that's what I need to review with you. If the p-value is less than alpha, we reject HO. You need to memorize this as much as you memorize the most important things in your life, because that's a key here for statistics. So p-value less than alpha reject HO, and p-value more than alpha fail to reject HO. Not accept, fail to reject. You know, when the court or the jury decides there is not enough evidence to convict a person, it does not mean that the person is innocent. They just don't have enough evidence to convict the person. And that's it. It works the same way for p-value. P-value more than alpha fail to reject HO. Okay. If you compare 0.086 with 0.01, it's bigger, right, guys? So you fail to reject HO here because the p-value is greater. Okay, what about 0.05? It's still greater. Fail to reject HO. Or not less, sorry. Greater. What about 10%? 0.08 is less than 10%, so you reject HO. So alpha makes a big deal. This is the level of significance here because the p-value is less than alpha. Just a warm up. Okay. Find the p-value for the indicated hypothesis. Test with the given test statistic Z. Decide whether to reject HO given alpha. Okay, right tail test. If you have to a right tail test, so the p-value is the area to the right of Z. So if you want to find it by itself without running a hypothesis test, guys, you just do a normal CDF to the right of Z. You don't need to do that when you do a hypothesis test, which is coming soon. But this is a separate question. So it will be 1.35 million. And then 0, and then 1. Okay, let's see what would that be. And if it was to the left of Z equal 1.35, then you start negative 1,000,001.3501. That's what the p-value, that's the definition of the p-value. So you go to second, distribute, normal CDF, 1.35, guys. And you can put 1,000, a million, whatever you want. So the p-value is 0.0885. Remember that. I forgot. Let me see. Yeah. Okay. Let's make a decision. Well, 0.0885 is bigger than alpha. You fail to reject HO. All right. Now an actual question. A random sample of 80 8th grade students score on a national mathematics assessment test has a mean of 267. So let's see what we have here. So N is 80. Mean is X bar is 267. The test results prompt a state school administration to declare that the mean score for the state's 8th grader on the exam is more than 260. So the claim that the mean is more than 260. That's the claim, guys. Assume that the population standard deviation is 37. Once he tell you population standard deviation, that's sigma, you must use a Z, guys. So it's going to be a Z test. This is how you decide between Z and T test. If he doesn't mention population standard deviation, then it's a T test automatically. Okay, let's select the null and the alternative hypotheses. So the claim is in the alternative, and you guys agree with me that null will be less than or equal to, so that would be the one. But for my section 98 and 99, that would be your answer, guys. Greater than 260 for HA and equal to 60 there. But this is not the claim. The claim will still be in the alternative hypothesis. Okay, this is a Z test. Let me show you how to perform this test, guys. Clear stat. It's the first test on the screen. And mu0, we are testing against 260. Sigma, you see, it's prompt you for sigma. What was sigma? I forgot. 37. So the word population standard deviation, guys, is a hint that you have sigma and then you must use z. What was the sample mean? 267. And n was 80. And we're testing. Make sure to select the alternative sign first before you hit calculate or draw. And z is 1.69. And p-value 0.0453. Decide whether to reject or fail to reject the null hypothesis. What's alpha here? Alpha 0.12. That's less than 0.12. So reject HO. And if you reject HO and the claim is in H1 or HA, you support the claim. At the 12%, there is enough evidence to support the claim. All right, let's go to the next one. Use a t-test. It's clear now. He's telling you use a t-test. He's telling you that the mean is greater than or equal to 8200. That's the null hypothesis. So the claim is in the null hypothesis. The alternative will be less than, because these are complement of each other. So which one would that be? That would be B. Again, for my section 98, 99, you will have an equal here instead of the greater than or equal. So just choose the equal. Okay. He gives you, he says t-test. So you must use a t-test, guys. So just go to stat. It's number 2. Stat. Okay, we're testing against 8200. X bar is 8000, guys. S is for, you see, it's S. It can't be a Z. It must be a T once he gives you S. And N is 20. And now choose the alternative sign, which is less than. And hit calculate. And T is negative 1.863 and the p-value 0.0390. And alpha is 0.05. So that's less than alpha, guys. And less than alpha, you reject HO. So reject HO, there is enough evidence to reject the claim. When you reject HO and the claim happen to be in HO, you just reject the claim. So you say there is enough evidence to reject the claim. This is what I've been telling you guys. When the claim is in the null hypothesis, your final conclusion should have the word reject. When the claim is in the alternative, your final conclusion should have the word support. An employment information survey claimed that the mean annual salary for senior level product engineers is 98,000. Is 98,000. The annual salaries in dollars for a random sample of 16 seniors are given here. Product engineers are shown in the table at the right. At alpha, test the claim that the mean salary is 98,000. So is and is not, equal and not equal. So you start mean equal 98,000. And here, you guys, it's for both a section. It doesn't change. The same thing, exactly same thing. 98,000. But we need, what you need to note, guys, here that the claim is in the null. So you can't use the word support when you write your conclusion at the very end. Oh, it says here, it's asking us. Okay. To do this, I won't be asking you to use the critical value. It happened that this one has a critical value approach. So I'm just going to do it with the p-value. Look how you can do this with a StatCrunch. Open in StatCrunch, watch. Oops. Sign in. Sign in. Okay, let me just go back. I'm going to open it in StatCrunch now. Now we should open. There you go. All right. So this is a t-test. Anytime you have a data set, guys, it's a t. So you're just going to go to stat, t-stat. It's only one sample with data. It's in variable one. And what we're testing against 98,000, just put 98,000. Put the correct alternative sign, which is not equal, and just hit compute. And the test statistic, guys, is negative 1.877. The p-value is 0.0802. And let's see what alpha here, 0.01. So 0.082 is bigger than alpha. You fail to reject the null hypothesis. And you say there is not enough evidence to reject the claim. So anytime you fail to reject HO, you start with there is not enough evidence. And anytime you reject HO, you start with there is enough evidence. Now, if you want to use this on the calculator, guys, you will have to go to stat edit and do data entry right here in L1. Put all the data in L1 and then go to stat, tests, t-test, select data, and select mu0, which is 98,000. And select your list, whether if it, let's say you put it in L1, and then you go here and you select not equal to. Make sure to select it. Just press enter and then hit calculate. You should get the same results as I got in StatCrunch. Okay, that's clear. My drawing. A humane society claims that less than 69% of households in a certain country own a pet. In a random sample of 400 households in that country, this is a proportion test. 268 say that they own a pet. At alpha equals 1%, is there enough evidence to support the claim? When the claim is in the alternative, it will ask us to support it or not to support it. Okay, so where is the claim less than 69% on a pet? Okay, what would be the null and the alternative, guys? That should be easy now. So we have P less than 69%. And you guys agree with me that should be where in HA or H1? And what would be your null hypothesis? The complement, the opposite. So for section C1, you would write this, 69%. And for my section 98, 99, you just put the equal sign here. You select the equal sign. That should be HO here. Sorry, it's not HA. All right. So let's select some answers. So we said it's going to be right here, 0.69 and 0.69. Okay, it's a proportion test. Let me show you how to run this test, guys. So clear, you go to stat. Let me clear the drawing. and it is a one prop Z test. A very easy test. It doesn't require much input. You will see. Okay, you're testing against 0.69. Just put it there. Okay, X. I forgot what X was. 400. Oh, not X, 268X. X is a smaller one. And then 400. And we're making the claim that it is less than, that's the alternative hypothesis. And just calculate. Okay, Z is negative 0.86486, and the p-value, guys, is huge, 0.1936. Which is more than alpha, you fail to reject HO. So fail to reject the null hypothesis. And we fail to reject the null hypothesis, and the claim is in the alternative, you cannot support the claim. As I told you, fail to reject, you start with there is not. Since the claim is in H1, you just use the word, select the word support. There is not enough evidence to support the claim. All right. Now we're testing comparing two means. A food manufacturer claimed that eating its new cereal as a part of daily diet lowers total blood cholesterol levels. The table below shows the total blood cholesterol levels in milligram per deciliter of blood of 7 patients before eating a cereal and after 1 year of eating the cereal as part of their diets. Use technology to test the mean difference. Assume that the samples are random and dependent and the population is normally distributed. At alpha equals 5%, can you conclude that the new cereal lowers total blood cholesterol levels? Okay, guys. For this one, you need to know that the two samples are dependent because it is the same patient before and after. When you see a table like this, guys, you know that you have dependent samples. And when you have dependent samples, guys, you have to work with the difference of the two sets. So we're going to subtract the data from the two sets and work, only with the difference. So it will turn out to be a t-test, just one sample. Now, we have to decide on the claim. If I want the cereal, just to lower the cholesterol, this is how I tell my students, just to figure out which hypothesis to select. Okay. So assume that their claim is correct. So if someone has a cholesterol level of 200, let's say 60, and if the cereal works, that means it's going to lower it. So what would be a lower number than 260? Then my students will tell me, let's say 200. And then I'll tell the students, subtract the two numbers. 260 minus 200 is what? 60. And is 60 positive or negative? They say it's a positive. So then I tell them your claim that you should test that the difference is positive. And I tell them, where would you find the difference is positive? They tell me right here. Now for section 98 and 99, you just put an equal sign right here. And that would be the claim. So the claim is in the alternative hypothesis. Now, how do you do this? By using the calculator. This is very important question, guys. You might see it on the final exam. So I'm going to do it using StatCrunch and on the calculator. So for the calculator, guys, you go to Stat, Edit, and I am going to try to do this. We're going to need to do the differences. So 210 minus 204. Let me just pause. So let me just repeat that one. Now I'm recording. So we put the data in L1, the differences in L1. Edit, let me just show you one more time. So all those differences that we subtracted, we put them in L1, and then I went to Stat, Tests, T-test, Data against 0. We put our data in L1. Our claim that the mean difference is greater than 0, you have to select the alternative sign. This is the alternative sign, guys. And then we hit calculate. And we got tested statistic 1.753. You put it in there. And then the p-value 0.065, which is more than alpha. We fail to reject the null hypothesis, and we conclude that there is not sufficient evidence to support the claim. Now, how do you do this in StatCrunch? Let me clear. Okay, open in StatCrunch. Stat, tstat, to sample but paired. You choose paired. Paired means dependent. Column 1 before, column 2 after. Save the differences. And you want to test greater than 0 and hit compute, guys. And here you go. Do you see the match? 0.0651, 0.0655. So to want me to repeat it again for dependent samples, you go to stat, T statistics, paired. Paired means dependent. They relate with each other. You select the first column, you select the second column, you select the difference, save the difference so you can see them, and you just decide on the alternative sign only. Just decide on the alternative sign. Greater than. Compute. Okay. So that's how StatCrunch works. Describe the range of values. The correlation coefficient is between -1 and 1 inclusive always. Okay, the order now of the questions changed a bit, but it's fine. Which value of R indicates a stronger correlation? What do you think, guys? Is it 0.721 or -0.893? Any feedback?
0.721.
Why is that?
It's closer to 1.
What about -0.893? Isn't it closer to -1?
Oh, yeah.
It doesn't matter whether it is negative or positive, as long as it's closer to 1 or -1. So actually, strong because in absolute value, it's bigger than 0.721. Okay, let's see here. I don't see the scatter plot. Oh, there they are. Okay. Which one is the strongest correlation, guys? First, second, third, or fourth?
Second.
Second, yes. So perfect positive linear correlation right here. Strong positive, okay. Perfect negative I don't have here. Let's see. Strong negative linear correlation, you guys agree that will be that one. And weak, no linear correlation is this one. This is not the linear, actually. This is a quadratic correlation. So that will be the one. And what about this one? Which one we're gonna use for this one? No linear as well. Yeah. Okay, well, I try to. Okay, let me just do that. So it will let me advance. The accompanying table shows the ages of 11 children and the number of words in their complete parts A through D. Okay, this is the data table. Calculate the correlation coefficient, describe the type of correlation, interpret the correlation, and use the table of critical values. So let's do that. I'm gonna do it using StatCrunch, guys, here. Will be faster. Okay, to show you how open in StatCrunch. Okay, for my C1 class, this is chapter 9, and for my section 98, 99, this is chapter 4. So you go to regression, stat, regression, simple linear, X variable is age, Y variable is vocab, and I wouldn't worry about the rest. And here you go. Watch, guys. The correlation coefficient is 0.9788. R square, which is the coefficient of determination. The S, if he asks you for the estimate of error, standard deviation is 212. And this is the equation, guys. Y equals negative 876.67 plus 573x. These are all the values there. So let's just put the value of R here, which is 97. How many decimals? He says 3 decimals. So 979. Wow, that's very strong. All right. And we're done here. Okay. And let me show you the graph, guys. The graph is right there, so you can select it from here. So when you want to match the graph, you already have it there. So that's very convenient to use a static crunch in here. Describe the type of correlation. Would you guys agree that there is a strong positive linear correlation? Or what was it? Linear, strong what? Let's just bring it back. Yeah, strong positive. Interpret the correlation. How would you interpret this one? So you have to select, so it's between age and vocab size. As age increase, people tend to retain, just more vocab words, vocab size tend to increase right there. Now use the table of critical values for the Pearson correlation coefficient to make a conclusion about the correlation coefficient. Let alpha equal 0.01. So let me bring the table up, guys, and show you how to use this table. Okay, so what's n here? I forgot how many did we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so n is 11. And we're doing it at alpha equals 0.01, so there will be 0.735. If R, an absolute value, is bigger than this value that you got off the table, then you can conclude that correlation is significant. And it is indeed. The critical value is 0.773. Therefore, there is sufficient evidence at the 1% level of significance to conclude that there is a significant linear correlation. If R turns out to be less than the value that you find in the table, you say the correlation is not significant. Two variables have a positive linear correlation. What do you think the slope, guys, is going to be, positive or negative? Any ideas?
Positive.
Yeah. The slope is positive. As the independent variable increases, the dependent variable tends to increase as well. Explain how to predict the Y value using the equation of the regression line. And you might have to answer some questions there if you have the equation of the regression line like this guy. If I give you the X value, you just plug it in the equation and find Y. That's all I'm asking you to find. So substitute the value of X in the equation and solve for Y. That's it. That's an easy question. Is it appropriate to use the regression equation line to predict y values for x value that are not in the range of x values given in the data set? We agree that it's not meaningful, guys. For example, if your x values, let me just, in the table, if your x, let's see, just wait a second until this works. Okay, if your x values, guys, are between 1, 2, 3, 7, 10, 5, 8, 12, let's say, and you have y values in the table as well. If I ask you to find the y value when x is 20, you tell me it's not meaningful to use the equation because 20 is not within the range of those values, so it's not appropriate. All right. But if I ask you find the y value when x is 8, definitely you should be able to do it because 8 is within the range. So it's not appropriate because the regression line models the trend for the given data, and it's not known if the trend will continue to work when you go outside of the range or not. So just remember that, guys. Okay, here's another question. Find the equation of the regression line for the given data, then construct a scatter plot for the data and draw the regression line. I'm gonna do this, guys, using the calculator this time because I haven't showed you how to use the calculator for this. So I'm gonna put the x values in L1, the y values in L2, and then, okay, we're back to this. So we missed a couple problems, guys. All right. Find the expected frequency I for the given value of n and pi. So the frequency will be the percent times the total. So there will be 0.24 times 210, and that should give you the answer right here. And let me just, so if you want to do it, you just do 0.33 times 180. And it seems like we're going to run out of time, but I will finish the rest and provide a separate video for the rest, probably for the ones we skipped as well. All right. Research firm claims that distribution of the days of the week that people are most likely to order food for delivery is different from the distribution shown in the pie chart. You randomly select 485 people and record which day of the week each is most likely to order food for delivery. The table to the right shows the results. Test the researcher claim. This is a goodness of fit test, guys. The goodness of fit test, HO will be the distribution is as claimed, and HA will be the distribution is not as claimed. So let's select the distribution of days of people order food for delivery is as shown in the pie chart, and the other one will be is not as shown as differs from the expected distribution. He said test the claim that they are different, so your claim is in H1, HA. Calculate the test statistic. Okay, for the test statistic, guys, you have to do some work before even you use a StatCrunch or the calculator. To use the calculator, this is what you have to do, guys. You have to put your data in L1, the observed values, the frequencies in L1, and you're gonna put the expected values in L2. So the L1 is already ready for you. So we're gonna put 45, you're gonna put the 10, the 21, the 40, the 49, 165, 155. Now the expected values. There's the trick here, and this is the mistake that students make here. Some students will just put the percents here. That's wrong. You have to put the percents of the total. So for Sunday, it's 80% of what? Of 485. So look what we're gonna do, guys. We're gonna put 0.08 times 400. Is it 485? Just one sec. Yeah, 485. Enter. For the next one, 5% of 485. For the next one, 7% of 485. Remember, it's a percent of the grand total. 12%, 0.12 times 485. 9% times 485. 165, 37%, 0.37 times 485. Don't worry what the answer is, it doesn't matter. And 22%, 0.22 times 485. Okay, and now you go to stat, tests, scroll up. It's a GOF test, guys. The GOF test is reserved to test when you have more than 2 proportions. Now here we have 1, 2, 3, 4, 5, 6, 7 proportions. Enter. Observed are in L1, expected are in L2. Degrees of freedom, guys, if number of categories minus 1. So how many categories I have? 7. 7 minus 1 is 6. And then hit calculate. And your test statistic, guys, is 43.679. And I'm done with this. And your p-value, guys, let me show you the p-value here. It's 8. Don't ignore the e minus 8. The e minus 8 means you have 0 answers. So you have to move the decimal place 8 digits to the left. So just put 0. Whatever he says. Well, definitely we reject HO because the p-value is less than alpha, and there is enough evidence to conclude that the distribution of the day's order for is not as differs from, because the claim is in HA. Now, how would you do this one in StatCrunch? Let me show you. You have to enter the expected values right here, guys. You will have to enter the expected value. You have to do them by hand and enter them right here, just like we did on the calculator. So you have to put the expected value here, and then you go to stat. So let me just pretend like I'm putting some values right here. Stat, edit. 38.8, 24.25, etc. So 38.8. You just have to do them, guys, manually and put the values. I'm just making up some values right here. The ones that we got on the calculator, the exact ones, guys, you just copy and put in there. And then you go to stat, goodness of fit test, chi-square test. You select the observed, which is the frequency. You select the expected value, and then you hit compute, and then you should get the answer. Okay, so that's how we do this. Okay, that's the last one that we do, guys, and then the rest of them, I promise that the remaining 15 questions, which still cover hypothesis testing for 2 means, 2 proportions, independence test, and an analysis of variance test will be in the remaining questions. That's a very comprehensive review, guys. But let me just do the last one. A researcher claims that the number of homicide claims by season is uniformly distributed. Uniformly distributed means all the seasons have the same number. That's what the word uniform means. To test the claim, you randomly select 1,200 homicide from a recent year, record the season when each happened. The table shows the results, test the claim. So again, for goodness of it, the distribution is as claimed and the distribution is not as claimed. So here we'll say is uniformly distributed. Here is not uniformly distributed. That means the claim happened to be in HO here. Okay, that's very easy to use the calculator here for this one. So we're gonna just go to L1 and clear it. L2 and clear it. I'm gonna do it with the calculator and with StatCrunch. 309, these are the observed, guys. 316, 294, 281. He didn't give me a pie chart for the expected values, a percents. How I'm gonna find the expected values? He didn't give me a pie chart, but he says uniform. Uniform means, guys, they are all the same. So each of the one of them is 25%. So what you do is you just take the 1200 and divide it by the number of categories here, which I have 4 of them. So 1200 divided by 4 will be 300. Just put 300 straight across the column. So that's the difference between uniform when the question is about uniform distribution. And, oh, I put more than one. Delete this one. One, two, three, four. It's not deleting, so I'm just gonna do it again. Okay, we're almost done, guys. All right. And stat. And I'll make this study guide available for my section 9. I'll make it available to you as well, guys, since some of you attended today. So it will be goodness of fit test. Degrees of freedom, what is it gonna be? Oh, I picked the wrong test, sorry. I said goodness of fit test, but I picked the other one. Degrees, oops, why it keeps doing this? Going too fast. There you go. Degrees of freedom is going to be 4 minus 1 this time, 3. Enter. Okay, 2.44, p-value is 0.485, which is bigger than alpha. Failed to reject HO. Not enough evidence to reject the claim. Because the claim is in HO, we use the word reject. Now, how would you have used StatCrunch? That's very easy here, guys. Look, I just put 300 all over. And let's do it with StatCrunch. Now we're gonna try StatCrunch. Goodness of fit test, chi-square test. Frequency, variable 3, compute. And you guys, you can see there's a match. It's exactly same thing. 2.446 is the chi-square and the p-value 0.485. Failed to reject the null hypothesis.